Okay, great. Like I was saying, you know, you had a lecture on this topic this morning. It's so foundational. It's such an important thing, callbacks, right? You're going to use them a lot throughout the boot camp. So this is a chance to hear the same material again. It's also a chance to ask more detailed questions now that you've had the lecture and worked through the Compass material on it as well. I would encourage you to turn on your video screens so that we can do the thumbs up, thumbs down thing. And, you know, reach out through the internet to make genuine human connections with people. We'll all forgive each other for not, you know, being on their game with regard to hairdos. And I mean, you know, I do my best, you know. All right. So let's talk about functions. Let's talk about variables. Let's talk about function parameters, right? These are values that you hand into a function that become values of variables inside those functions, right? And then the last piece of the puzzle is that those variables themselves can be function valued. And I think that's the hard part. That's the bit that people struggle with, is that last step. It's one thing to imagine making a function that takes a string parameter or an integer parameter, right? But what about a function that takes a function as a parameter? Why would you ever want to do that? How would you do that? That's going to be the subject of today's lecture. So what I'm going to do first is share the screen. And I'm going to show a very basic example of a function that takes another function as a parameter. So, sorry, let me click the share screen, share the screen. Can everybody see that okay now? Yeah, good. Thank you for the thumbs up. The video cameras do help. Good. So here we have a function that I'm calling supernova. All right. And of course, there are a variety of ways to do the syntax for defining a given function, right? In this case, I'm using an arrow function. This is a function that's going to take two parameters. Actually, you know what? Let's just chop this one out for now. We'll only take the one parameter. Like this. And right now we're ignoring the parameter. We'll get to that in a minute. So supernova is a function. And when I call that function, you can pass in a parameter and it will do some stuff. It's going to choose a random number and then it's going to console log a string. That's basically the size of that thing, right? So that's all well and good. Let me call that function now, supernova, like so. And I'm going to call it with no value for the parameter for now. Right, so 10 breakout example. We'll go to the directory. Where am I? It's here. Sorry, I was in the wrong directory. Sorry, where am I? I've lost track of where I am. Oh, week 1, day 4. Okay, I've actually attached this to today's. There we are. Okay, so if I type node breakout example, this is the code that I've got running here. Okay. So here's our function, supernova. In fact, why don't we start up a terminal right in this directory? Then both things can be on the screen at the same time, right? node, breakout example. This is not working, and that's fine. We'll get rid of that terminal. I can flip back and forth between here and here. I hope that that's okay for folks. Okay, so when I run this code, it runs my function. That function writes out some text, which, by the way, happens to be the steps that occur during a supernova. First, there's a huge explosion, very rapid. The next step is that a bunch of neutrinos are released. Did you know that 99% of the energy that comes out of a supernova is released in the form of neutrinos? Very weird, subatomic particle. There were about a dozen neutrinos detected from a supernova in 1987. This was a huge deal. Happened in like a little mini galaxy next to the Milky Way. The next thing that happens is that the light from that supernova is generated. So if you're really on the game with your neutrino detectors, it's theoretically possible to get a warning about where the supernova occurred and then turn your telescopes there to see the brightness of the supernova come to life from nothing. That's a thing that people are trying to make happen. I hope it happens in our lifetime. Then there is awe. Yeah, that's clearly the fourth step when people see the supernova. And then finally, we've got this random number generator to pick the size of this particular supernova, right? So there you go. If I run this function, this stuff happens, right? Cool. Now, there are reasons for a thing to have parameters. There are reasons for a function to have parameters. Right now, I've included a parameter called process the size. We'll get to that in a minute. Let's actually add in a new parameter called max. And this is going to be the maximum size of my supernova. All right. And so for this, let's go asterisk max. And so what this is going to do is the random number will be between 0 and 1. I'm going to multiply that by max. So if max is like 100, now my supernova sizes can go up to 100 each time. And so when I pass in a parameter to my supernova, let's maybe 100. That could maybe be the biggest size supernova that I'm interested in. Okay. So great. We go ahead and run this. There's a supernova of size 41, 45, 7, 53, 88, 60, and so on. Every time I call the function, I'm getting a new supernova up to a maximum size of 100, chosen at random. Great. That's a good example of needing a parameter on my function. That parameter was a simple integer number that I passed in, a simple number. It means that this code is capable of doing a thing, but that thing has been parameterized, right? I could later on call for a second supernova, but now it can be up to size 10,000 instead of 100. My second supernova is going to be up to quite a bit larger a size. Always the second one, small one, then large one, right? And all I had to do to call this function is just to call it again with one line, give the name and a new parameter, right? So if I do this now, I get two supernova, and always the second one is being plucked, whoops, from a pool of supernovae that are larger, right? Now, it's theoretically possible for the second one to be smaller than the first one. It's just highly improbable. Yeah. And we're playing around with the physics of this just to demonstrate how functions are used, right? We're parameterizing the function's tasks, its processing, if you will, and feeding that processing an input, And the input is a way of abstracting out a control on that action. All right. So we've done that with just a numerical value here. What if we want a little bit of the processing that goes on in here to also be parameterized, right? So that's what callbacks are for. You're going to add another parameter to this function, and we're going to say process the size. Okay. And what we're going to do is we're going to pass in now a function value for a parameter to this function, and it's going to parameterize a bit of the processing of that function. So that was a theoretical description of what we're about to do. All right. If you understood it as is, just the way I said it, great. But at this point, what I want to do is really step back and really get to some generic language about what's going on here that I hope when I say that stuff again and show you an example, it's then going to be easier to comprehend what I just said. Okay. So let me back way up and now talk about things from like the 30,000 foot level, right? Way back. I'm going to say something that's kind of controversial, but in a single sentence will be very, very powerful for understanding all of computing. Okay. And it goes like this. Every bit of computing can be boiled down to three things: inputs, processing, and outputs. Now, a function is kind of a little microcosm of all of those three things. But let's stay backed way up from the 30,000 foot view, okay? I said, and it's a strong statement, everything in computing can be boiled down to inputs and processing and outputs. Let's think for a moment about a web browser, right? That's part of computing. The inputs to a web browser are the web address that you type into the URL bar. Go ahead, type it in, hit enter. That's the input. The processing is retrieving information, sorting through that information to decide how it's going to be rendered. And then finally, the third stage, output, is the actual drawing of the rendering of that information on the screen. That's the output. Okay. Let's think about this exact example here. I have an example of some computing, right? This is a function that's modeling a supernova. It's not a very good physics model, by the way. It's just a supernova. It's like a little trumped up supernova model, right? But here it is, this function. It's got inputs and processing and outputs. So let's look for each of those three things here. Yeah. So this function supernova, these are the inputs here, the parameters. It's also, by the way, taking an input out of the math object called random, because clearly the output depends on this thing. So you can think of that random number generator as one of the inputs to the calculation. So not all inputs are necessarily in the parameters, but in special cases, you can restrict it so that you only want to use the parameters for your inputs. We'll come back to that topic much later in the boot camp. But there you go. There are your inputs, right? Now, processing. Well, Here we have two lines of code that are doing processing. I would argue that this line is the processing, right? It's calculating a size based on the random number times the max. Yeah. Now, with that processing finished, then we move on to the outputs. And in this case, the output it's what's called a side effect of this function. It's just going to write it out to the console, right? It's actually output. It's text that's output to a terminal. It's pretty clear that in this case, that line is where the output is coming from. There is another way that you can do output from functions, right? You can go return size like this. That's a fairly classical way for a function to return some output from that function. So let's just include that here just for fun. So that you can get the idea of where the output parts are, right? Okay, so again, we've got inputs and processing and outputs. And so for this function, as is, like without that parameter, right? Here, max is definitely one of the inputs now. The processing happens here, and then we get an output. And so that when this is run, you know, we're seeing the output each time it's run. Now, a callback is going to be an input to this function, but now it's not just a numerical input or a string input or something like that. It's actually in and of itself a little microcosm of processing that could be arbitrary, right? That it itself could have its own inputs, processing, and outputs. But that little microcosm of processing is going to get handed into this function as an input to it. All right, so let's bring that back. There's our callback, process the size. And now we've got a size here, and we're gonna do some processing on that size now, okay? And so to invoke this callback, to actually execute the function, let's just go ahead and do that, right? We know that we have a variable that's function valued. Do folks know how to call a callback just based on their experience from this morning so far? How would I call this function at this point? Okay, so the way that I call this callback function is to say process the size, right, with little smooth parentheses next to the name. That is in and of itself a function call. I'm now executing that function, right? Whatever that function is defined as, I'm going to run it. I'm sorry, I've been missing stuff in the chat. Let's just see here. Okay, we're just laughing about the neutrinos. Good, I'm happy about that. Okay, back to the code. Okay, there. Here we are inside our supernova function. We're going to process the size. Now, I think it makes sense to process the size by actually passing the size into that function as a parameter, right? Because that's how it can process the size. It's going to take the size as an input, process it, and then return a value back out, right? So let's say we have const result. By the way, this is how you capture a return value from a function, is you use that function on the right-hand side of an assignment operator. Yeah. So process the size, that's a callback function that was passed in as a parameter. I'm going to execute that callback on the size that we got, and the results of the processing on that size are going to show up as the result. Okay, so let's change the output now of our supernova function. This is the size, comma, and then we've got some more text that's going to say the result of processing the size, like that, comma, and we'll say result. Do people notice in their editors how when I define a variable like this, as I'm typing, as soon as the editor recognizes that I've typed this thing, it brightens it up? I find that super useful in VS Code, right? It's like, oh yeah, here's a variable. It's a variable I'm not yet using. But as soon as I've typed it in, it's like, oh yeah, that's a variable, but I'm using it now. So I make it a little bit brighter. That's, if you see and notice that, you're going to catch typos and stuff. I think it's pretty cool. Okay, but now what we've got, our supernova function is a little bit more complex. It's taking in a callback. We're executing that callback. We're processing the size value that the supernova comes up with, and we're going to capture a result of that processing and then include it in the output of our function. How about one more modification to this function? I'm going to go const output equals, and I'm going to take this whole string and set it to the value of, set the value of the output variable to match this. So in this case, I'm going to switch this to backticks now so that I can do string interpolation. And I'm going to put in like $ and curly braces and then variables like this, right? We'll put the size there. And again, $, curly brace around size. Okay. Are people happy with the changes that I just made? People are okay with the prep work that they've done up to now. They recognize this sort of syntax trick I just pulled. What I'm doing is I'm saying, this is a thing that I want to be my output string for this function. And I'm going to do two things now. I'll console log it here. I'll say output, that's my label. And I'll say output for the variable. Watch how it brightens up as I type it. And then instead of returning the size, now I can return output. So that little trick I just did, it made it so that I have one value and I'm always certain that I'm going to console log it and return the value as a return value here. Okay. Now, our function's getting a little bit more sophisticated, a little bit more tweaks, right? But we've set it up now to take a callback, but we've not yet called the function by passing in a callback in. That's the change we're going to make next. So Monty has a question. Couldn't you put the output directly into console log without giving it to a variable? Absolutely. Yeah, I could have taken this string here and put it in place of output. That would make it a convenience. That would eliminate this output convenience variable. But the reason that I set up this convenience variable was so that I could use it twice. And then I would only have one place to edit that, and it would force my console log and my return value to be the same. So that was the reasoning behind that little edit like that. I absolutely could have done it the way that you suggested. It would just be maybe a different purpose, but there's an advantage to having something in a variable so that you can use it over and over again. That's almost always the point of having a variable name, right, for a value. So that's what I was thinking anyway. Okay, so here we are calling supernova now twice. In fact, let's call this thing 3 times, except with sizes up to 100, then 1,000, and then 10,000, right? That's the advantage of having a microcosm of computing in the form of a function, is that it's easy to call it a 3rd and 4th and 5th time with different parameters. Okay, so all of this has just been a setup, right? Now is my chance to pass in some callbacks. And in each case, we're going to process these values in slightly different ways because we've abstracted out the processing of the size in our supernova function, but now's our chance to get specific about what it means to process the size. Yeah. So for example, in the first one, I want to pass in a callback here, right? So what is a callback? It's a function definition, right? If this was a string, I'd type in a string at this point, but I'm not trying to type in a string. I'm trying to type in a function definition. So let's go ahead and do this. There is a function definition. I am passing in a callback. Right now, that callback does nothing, but it's still a valid syntactically correct callback. Okay, let's see what happens when we run that. Next up, I'm going to pass in a different function definition for that very same callback parameter, right? But now it's going to be a different function definition. About syntactically correct, by the way, I'd like to pass on a certain kind of allergy that I have as a computer programmer. I'm kind of allergic to code that's not syntactically correct, right? It makes me feel itchy, right? It makes my eyes bleed, right? Whatever. I get a little bit vibrating, okay? And I want to pass that on to you as a kind of a contagious disease by words and teaching, okay? Basically, it goes like this. As I'm typing my function definitions out like this, if I do that and I have a thing that's not quite syntactically correct, okay, I feel weird. Like I'm not going to start typing console log at this point because I don't have a thing that's syntactically correct yet. Right? I need to close my curly brace before this is syntactically correct. In the middle of typing out this function definition, I feel itchy and weird. It's not until the moment that I actually, I finish this, my editor's happy, I have a thing that's syntactically correct, I can relax, my mind can move on to the next step, knowing that I haven't left a mistake behind me. Yeah? So I would like to encourage you to do the same thing as you're coding. It's like, basically, you know, hold your breath while you type a thing that's not syntactically correct until you get to the point where you've got a syntactically correct thing in your editor, right? Now your editor is actually going to help you because it inserts curly braces and stuff to make them all match up and whatever. That's kind of the end of my rant about like moving in between one syntactically correct thing and another, right? What have I got here? This is a function definition. It's a blank anonymous function definition, but it's still syntactically correct. If I highlight it with my cursor, just the function definition now, and I cut it out, it's like you can see from the syntax, yeah, I've got one parameter that I'm going to paste into this function execution call, right? There it is, my blank function definition. Now I can put my cursor in between these two curly braces, right? And here's the power of this approach. Right? White space doesn't matter in between your tokens in JavaScript, right? White space only matters inside a string literal. So I can hit enter at that point. Enter's just a piece of white space. I still have a syntactically correct function definition being passed in as the second parameter of my function call to Supernova. I just hit enter. I still feel fine about this. But this new blank line means that I can type arbitrary JavaScript syntax in here, line after line, could be loops or function calls or whatever the hell I want to put in here. And I can feel good about the fact that I've got a syntactically correct thing. Yeah. What ends up happening is this particular triplet of characters, right? Close curly brace, close smooth parenthesis, semicolon. That triplet starts to look like a single ending bracket character for the opening of a function that takes a callback as a parameter. You start to think of this as the opener tag and this as the closer tag, right? Because in here, I can just do whatever in it. And I've got like tabula rasa for new JavaScript, fresh and clean start. Yeah. Okay. So now I'm thinking, okay, how do I want to process this size, right? Okay, so it turns out that the way that we hand in these callbacks is that the callback itself takes the size as a parameter. So I should be making my callbacks to take size like that as the parameter, just the same way. That's the kind of function definition I should be handing in here. Just to make it clear, I'm going to call this one the size, just so that it's clear that this is its own scope. Okay, I could have named this variable anything. If I call it the size, it's still self-documenting, but it's clear that it's a different variable from the one that's used here, right? Here, size is a constant that's declared inside this scope, and it's passed on to the callback in this way. Here is the callback receiving that value as a new variable inside this scope. Fine. So what are we going to do? Well, how about for this version of the callback, let's make a switch statement, and we're going to switch on the value of the size like this. Can I do this? No. I take it back. We're not going to do a switch. We're going to do ifs, so I can be explicit about something in particular. So if, now in this case, if now we have supernovas that are up to about 1,000. That's the max here, right? So I'm going to say if 300 is if 300 is greater than the size, then I'm going to return a string that says tiny. Else, if $600 is greater than the size, I'll say return medium. And then finally, a catch-all for every other case, return massive. And save like that. Okay, I'm going to space these out a bit so that you can see the individual functions, that they're not visually too cluttered for now. Okay, all right. So what I've done here between lines 13 and 21, when I highlight the entirety of this section of code, I ask myself a question. What is this? What is this thing that I've highlighted in its entirety here? Well, that is one function call. I am calling the supernova function, and I am passing into it two parameters. The first parameter is 1,000. The second parameter is all of this stuff. That thing that I've highlighted there now, that's one parameter. It is a function definition. It is a callback that I am handing into the supernova function, right? That is a single value that's getting set when supernova executes, right? I've got supernova. Here's the definition for supernova. When the supernova executes, process the size. That's the function name now. Once you've executed supernova with this as its parameter value, this function definition for the second parameter, process the size takes on the value of this function definition. And so when process the size gets executed, which function is getting executed? This one. And so for this middle call to supernova, we should start to see some tiny or medium or massive coming out as the result of processing the size, right? And these numbers, the 300 and the 600, they're clearly chosen because, you know, size is relative, right? In the case of a set of supernova up to a size 1,000, then if it's size 250, that's kind of on the small end. And if it's size 500, that's kind of in the middle. Yeah. Okay. So let's, you know, quickly make another function down here. Actually, let's do this a third way. This will be super interesting. I'm going to make another function. I'm going to define another function outside of the parameter space. I'm going to say const big processor, like that. And I'm going to say that that is itself a function definition, like so. And that function will take a size as a parameter. And then we're going to just do something in here. And this one, the only thing is going to be if a size is less than, this time, 9,000. We better make it because so it's going to be somewhat probable. If it's less than 7,000, then we're going to return not quite supermassive. Say, whoops, what did I do? Not quite supermassive. Okay, so yeah, this is a function, big processor. It takes in a size just like this other one did. And if the size is less than 7,000, it's saying, oh, it's not quite supermassive. Okay, this big processor, yeah, that's a function. This is a variable that's function valued, yeah? Great, that's function valued. I can stick that in here as my second parameter to supernova, no problem. It's still a callback, right? It's just that I've defined my callback outside of the function execution itself, but it's still syntactically valid to do it that way, right? So when you're using callbacks, you're going to see all three of these things. You know, you might see an arrow function with a bit more fleshed out code than this one has. Or you might see this style of function definition passed in as a parameter to a function call. That's a callback, right? It's defined like right in line with the execution itself. Or you might find that there's an external function definition that's put into a variable name. And you can just pass that variable in as the second parameter to a function, still called a callback when you do that. All right, let's run all three of these and see what we get. All right. So if we look at the code, the first processor is always returning undefined. It's executing, it's just got no return value. You know what? Let's change that by putting in return 42. That's the only processing that the first processor is going to do now. It's always going to say 42 for that one. Okay, so we'll rerun it. Sure enough, we get our 42 here. And now let's look at some of these sizes. Doesn't matter what size this first one chooses, up to 100, it's still going to say 42 is the answer. Here's one that's 624. You'll remember that one was up to 1,000. That's calling this one massive because it was greater than 600, I think, right? And then for the last piece of processing, the size was 6,875 and change, right? It's saying not quite supermassive. For that case, let's run it again. This time 3,000. Yep, not quite supermassive. Run it again. Okay, turns out if the size is over 7,000, we didn't return any value and we're getting undefined here. I did see that, was it Sarah had a question?
Yes, I wanted to ask which one of these approaches kind of best practice, or it depends on the situation. I mean, having the function declared out of the, parentheses, or I
Yeah.
don't know.
Yeah.
Yeah.
Yeah, you know what? It totally depends on the situation. You'll see both.
Okay.
I would say in terms of what's common, I would say maybe this is used most often because callbacks are often used. There's just the one place where you need it. So you would be tempted to do it this way often. But certainly if you're going to use the same callback in multiple calls, then you might see something like this happening more often, like that. But I think the thing that I'm really trying to drive home here is that when I say the word callback, what I mean is that that's the parameter of a function, and the parameter itself is function valued. Doesn't matter whether you're doing it this way or this way, that's still true, right? Here I am calling supernova, where the second parameter is a function value. Here I am calling supernova, where the second parameter is a function value. Both syntaxes are the same concept. This one looks a little harder to read, right? Because this, I had to highlight from the beginning of the word function right down to the end of this purple curly brace, but not including the closing smooth parenthesis, right? That's how fine-grained I had to select. Like if I do my standard trick of cutting it out so I can look and see that the syntax makes sense, I had to be careful about how I was selecting that portion of the code. But yeah, here my second parameter is gone. Here my second parameter is back. When it's gone, I can see that it's clearly a function call with a second parameter about to go in. When I put the thing back in, here's my entire highlighted second parameter. It's a complete function definition as the second parameter. Okay, that is what a callback is. That's how a callback works. Cool. Okay, so we do have some questions. Around why do we use callbacks at all? Yeah. In fact, I'd like to challenge you all to start typing out into the web chat. Why do we use callbacks? This is going to be a hard question to answer, but I'd like everybody to try. Okay. And don't worry, what we're going to do is everybody's going to hit enter on the web chat at the same time. So it's going to be fair. Okay. You can choose to send it to me privately if you're shy. That's fine. Okay. Not everybody has to see it. If you're super brave and you want to admit that you don't know everything, or maybe you do, it's super cool to just send out some random answer into everyone, right? It's fine. Either way you want to go is fine by me. Give me your best answer. Why do we use callbacks? And after we see all the answers, I'm going to tell you my own reasoning around why we use callbacks, when you might want to be doing this kind of stuff. Turns out we're a little bit, don't hit enter on your answers yet. Ashley's beat us to the punch. Way to get your answer in first, though. I will commend you for that. Okay, and so everybody just prep your answer, and then we'll all hit enter at the same time. Okay, in fact, I'm going to do my own as well, just for fun. Okay. Raise your hand when you're done so that we can all hit enter at the same time. Okay. Either digitally or visually is fine by me. People are kind of like halfway done. This is a fun game. I'm going to do this more often in Zoom chats. Yeah. Okay. I'll go for that. People are hitting enter. Okay, go ahead. Everybody hit enter on your answers. In fact, my answer went to a private message. I'm going to go back and paste it again to everyone so that everyone sees mine as well. Okay, and then let's read through them and see where people are at with their understanding of this stuff. Easier to track down code that is created for different behaviors. Yeah, I would argue that any function would do that. Formatting code when it's big and verbose. So you mean like compartmentalizing code? Yeah. Yeah, I would argue that functions do that too. To make recurring calls. Yes. Again, I think just any old function does that as well, right? Callbacks make sure that a function is not going to run before a task is completed. Oh, there's some sophisticated asynchronous code thinking in that. This is a topic for next week, interestingly. It is part of the answer, my own answer. Keep the main function more organized and readable and more usable. Yes, I would argue that functions in general do that as well, right? Not just callbacks. To run the instructions in the callback, sorry, this one's sent in private. I won't read it out, but it's fine. Okay. To reuse functions that are created before. Yeah, I would argue again, functions do that as well. Just, I mean, every function. Callbacks are functions, but you know, the reasons that most people are giving are handled just by functions. You wouldn't need callbacks for this. Callbacks are kind of a specialized thing, right? To help pass in processed outputs as function parameter. I would take the processed output could just be a string. I could just hand in a string to that function. So that each function can have a very specific function. And if it needs to do something different, it will let another function do it for them. Ah, okay. That's a sentence that describes kind of like I'm going to say that same thing in a different way, I think. You can solve more complex problems, do more things. Yeah, that's a very general way of saying it, but yes, that's true. I mean, you could say the same thing about functions because why not? Best answer yet. Yeah. Okay. Reusability. Yep. To have your code in an efficient way. Good. Okay. So here's my answer. We use callbacks. Now, this is a really super specific thing that has to do with asynchronous code that you haven't learned yet. Right. So don't feel badly if you don't understand exactly what I'm about to say here. It's going to come later. And it turns out you're going to do that a lot in the boot camp, but it has to do with retrieving the output of asynchronous code. And at this stage, you don't know what asynchronous code is, right? But you will soon. And when you hear about asynchronous code and how it works, you can think now, oh yeah, I remember what Nally said. It's like, if I need to retrieve the output of some asynchronous code, I need to use a callback in order to get that output back out. I can't use a return statement in the case of asynchronous code to get output out. Now, if you can file that away in your memory and bring it back when you need it, I'll be real impressed, right? But at least you can see now why we're teaching you callbacks now. It's so that later on, when it comes to teaching that more sophisticated, difficult thing, you'll have callbacks under your fingertips, right? Okay, or another separate reason to use callbacks is to compartmentalize, to genericize some kind of processing that you're going to do. But when you're writing one function, you actually don't want to specify in that function how the processing is going to be. You're going to leave it up to the person who's calling your function to specify that part of the processing. Okay, so that is what we did here in this example with the supernova, right? Say I'm a physicist, I'm writing some supernova simulator things, and I'm like, yeah, I can make this awesome one-line supernova simulator that picks a size for a supernova explosion, right? And I'm going to leave the processing of that size entirely up to the person who calls this function. I don't want to specify how it gets processed. I just want to pick the size. In fact, a better name for my function might be supernova size picker, right? And so with my supernova size picker, all I do is pick the size. I leave the processing entirely up to the person who calls this function. That's a strong example of when you would use a callback, right? It's you're writing a function and you only want to write a certain part of the whole processing. And you want to leave a piece of the processing up to the calling end of the equation. Yeah. Okay. So we're coming up on the end of time for this breakout. I mean, not the end of all time. That's an open question. Any questions at this point? Otherwise, we'll just, leave it to the recording and let people watch this at double the speed after the fact. Yeah. All right. Going once, going twice. That's a wrap. Thank you for your attention. Thank you for sometimes turning on your screens. Thank you for the thumbs up and down. Thank you for playing along with the web chat game of everybody hit enter at the same time. I thought that was fun. And yeah, see you sometime soon. Week 3, I've got a breakout on command line tips and tricks that I hope you'll join in for. I'm doing an advanced lecture for week 10, so many months from now, on a solar system simulator, just for fun. Yeah, that's all she wrote. Happy working with callbacks. Cheers and thank you very much.
Thank you. Bye.
Bye. Thanks.
Bye-bye.
Thank you,
You're all
bye.
very welcome. Hope to see you sometime soon.